Hello, hi guys. My name is Abbas. Today we are going to solve a Leetcode problem, which is Leetcode 3418. And in this problem, what we have to do is that we have to maximize the amount of money which a robot can earn while moving from a top left corner on a given grid to its bottom right corner. So let's see. Let's first study the whole problem, what it is saying. As it is have given M cross and grid in which a robot is present on the initially at top left corner on 0, 0. Now it have to move to a bottom right corner, which is minus 1 corner to n minus 1. And it is stated that the robot can either move towards its right or towards its down. Now the one more thing is also given in the as it the grid have some values present on each cell. Suppose if the cell have a positive value, in that case the robot will gain that amount of points. In the case if the cell value is negative, in that case the robot have two possibilities. Either he will encounter a robber and robber will does what? Robber will steal the absolute value of that coin I comma j means the absolute value of the uh, coins value present on that set. Either and the second case is that the a robot have special abilities. What does special ability does is that it neutralizes the robber. Neutralizes the robber means it prevent the robber to steal that amount of coins from him. But what is the catch in this problem is that the robot can apply its special ability at most two cell only while moving from the top left corner to the bottom right corner. And one note is also given is that the robot can have total coin as negative as well. So there is a no assume as assumption which we make is that the total coin will always be positive. So here it is already given that the total coin can be negative. So what we have to do is that we have to maximize the profit the robot which he can get while moving from the top left corner to the bottom right corner. So from reading this problem, what we get is that it is a typical BP problem, which we already know as it is a DP on a grid problem, category-based problem. So it is a basic problem of a DP. So first of all, as we know that while solving a DP problem, first you know that what will be the variables which are varying from one state to another. So let's think about that. Suppose any as it is given that the our suppose that our robot is present on a some general grid on some general cell value. Let it as a coordinate I comma z. Now, if the robot will move it towards its right or move it towards its down. So while moving from one state to another, what are the variables which are changing? We can clearly see that the variables which are changing is first is I comma j, I that is x coordinate, and second is a y coordinate. So it is a 2D DP. It must be a 2D DP. Now one catch is also there in this problem is that the robot have some special ability and the amount of time the robot can apply this special ability is twice, two times. So we also need to know at a particular point of time whether the robot have some special ability on that point of time or not. So there is a this is the catch in the problem is that we have to maintain one more variable which will tell us at each point of the time that the in this uh, in this particular amount of at this particular time whether the robot have some special ability left or not. So there are the three variables which are changing when we move from one state to another. So it, I think after that there is no other changes which are taking place when you move from one state to another. So we can clearly see that this is a 3D DP problem. After that, the second thing which we need to know while uh, solving a DP problem is that what a particular state means. Suppose as we already as we came to know that this problem is a 3D DP problem. That is a DPY comma suppose a special ability SP. So what this state means. What this state means, we must need to know while solving a DP problem. So let it as uh, dp x comma y, or we can say dpi comma j and sp. We can write any of them from. So what this special state means in this problem? As we know that the robot is initially present on 0 comma 0. So while moving it's toward the bottom right corner, let it a general coordinate as I comma j. So but in this problem, the dpi comma j, what does it mean? dpi comma j sp means this 3D dp state. What does it means? That this is the maximum while moving, is that the robot have earned the robot has earned the this dpi comma j, dpi j sp means the maximum amount of coins which a robot will able to earn while moving from while starting from a coordinate 0 comma 0 to I comma 0. So this, and having a special ability left as sp at that particular point of time on that particular set. Let it here, here it once more. It is a very important concept. The DPIJSP, what does it mean? It means that the robot, the maximum amount of coin which a robot can earn, whether it moves from any path. If this will start, the DPIJSP stores the optimized value, means the maximum profit which a robot will be able to earn when it's moved from 0 comma 0 to coordinate I comma j, and the amount of special ability left in him at coordinate I comma j will be represented by sp. So what does it mean? dpij state that the maximum amount of profit which a robot will able to earn when it's moved from coordinate 0 comma 0 to the I comma j, and have some and have special ability left as a sp which will be stored on a variable sp. So this is a very important concept which we need to know. Now, I think you will be able to understand which I have explained in this problem. So now let's start the code. So first we will find the dimensions of our grid. So dimensions of our grid will be given by n, and after that will be the y coordinate will be a y dimension will be find with the minus I comma 0 minus size. After that, let's declare a DP, a 3D DP, uh, vector of vector. Let make as it is already given as int, so DP. So that we will resize this DP. Resize DP. We will resize this DP with n plus one coordinate as, and after that vector of vector in, we will make n plus one, and after that vector in, we will make 3. As the special ability can be used at most 2 times, so we have taken 3 so that there will be no overflow in that case. Suppose it is happen. And what would be the default value which we will take? This is the important thing which we need to know. What the default value, as in most of the problem while solving DP, while solving most DP problem, we take default DP value as -1. But one catch is here that we can't take the DP value as a -1, because the optimized value can be negative as well, as it is already given that robot total points can be negative. So we have to take, and it is also given that we have to maximize the profit. So it is pretty well known that we have to take some negative value. So we have to take that negative value, which can never be possible while in any of the example, or in any of the example in this problem. So what is the maximum negative value? What is the So we have to find the range of optima. We have to find the range up to which our optimal solution can go. So this we can know from our constraint, as it is given that the constraint value can go up to 500, and the coins value is lies between minus 100 to 100, minus 1000 to 1000. So the maximum negative value will be what? M cross n into 1000, which will be the power of 10 to the power 10 to the power 3 to 5. 10 to the power 5 into 25. This 25 into 10 to the power 5 will be the maximum negative value which a path can have. So let take as a let make as a one. variable int esp, which will be the -1 e to power 9, as because this is the negative value which will never be came in the optimized solution. So we have taken the list, so we can take the we have taken the negative value which will never come in the solution, so that the no problem could occur in further while solving this problem. So instead of taking this, we have taken esp. Now we will declare a function which will return our dp, which has a max amount similar as that one. So what are the variables? First variable will be the I as coordinates, second will be j, and the third variable will be the special ability, that will be as a sp. And we need to store the dimensions of the grid and comma on, and we need to pass the grid as well. Let the grid will be as this. Now let us think what will be the base case. The base case will be the case when the robot will reach to its bottom right corner. So the bottom right corner will be if I is equals to n minus 1 and j is equals to m minus 1. So the robot will reach to its bottom right corner. Now the bottom right corner, the cell value present on the bottom right corner can be negative as well as positive. So we need to know whether the bottom right corner value is negative or positive. If it is negative, suppose if it is negative, then we need to check whether we have some special ability left or not. Because there is no point to not using the special ability if we have a special ability at the bottom right corner. Because on the bottom right corner is our end, which is our base case. So it will be preferred to use the bottom our special ability, because there will be no point if we have special ability on the bottom right corner and we are not using it. So we will check if whether we have special ability greater than 0. If it is possible, then we will return. In this case, what we do, as if we are using a special ability, so here we are using a special ability. So in this case, what the special ability does that it neutralizes the robber from stealing that amount of coins present on the bottom right corner, or we can say the on the n minus one comma coordinate to n minus one comma coordinate. So what? So in this case, we will return 0. If else, and in the other case, what will happen, that in the other case what will happen? Else, in this case, what we need to return? We need to return the coin I comma j. This will be the case if we do not have any special ability left. Suppose what will happen if suppose the coin value is not that particular cell, bottom right cell, have value which is to be which is as a positive. So in that case, we simply what we does, we in this case we will simply return the coin I comma j. Now, uh, s- uh, here we are solving with the top down DP. So we will check whether this particular state is already visited or not. Means this particular state value is already calculated or not. So if it is already calculated, so in that case we will return the dpi comma z and sp. Now we are solving the particular generalized case. Now we are at coordinate I comma j, and I have some special ability left by the sp. So when we are standing on a particular coordinate or on a particular cell, so on that point we have two possibilities left. Either it will move, the robot will move right, other either it will move down. So we need to make two variables, which is int right value, which will give the maximum right value, which will be able to robot will be able to earn if it's moved from coordinate I comma j to the bottom left corner. So the right value will store the maximum amount of coins which a robot will able to earn if he moves from this particular cell to its right cell. Means the next step it will take towards its right. So in that case, the maximum amount of coins which a robot will be able to earn will be represented by the right by a variable right value. Initially, we will initialize as ASP, and same for the down. If the robot moves towards its down, so the maximum amount which our robot will be able to earn when it's moved from a coordinate I comma j to the bottom left corner, bottom right corner. So this value will be stored in the variable uh, down well. So let it be as a default value GSP. So we are solving the first case. It's the right value. So suppose we are standing on a coordinate I comma j. So before moving to the next right coordinate, we need to check whether the next right coordinate whether it exists or not. This is a if we will not check, then it will give a buffer overflow. Means what we it will what happen that in the case suppose our robot is present on a particular row on the rightmost column. Suppose our grid is a 3 comma 4. So let our robot is present on some coordinate 1 comma 3. In this case, it is present on the rightmost coordinate. Suppose let here as a 1 comma 3. Suppose it is present on 3. So in this, the robot have no space to move on the right. So first we need to check whether it is feasible to move on the right part or not. So we have what we do, y plus 1 is less than m. If it will be less than, in that case, the robot will be able to move on right. Suppose move right. So now we are standing on a particular coordinate I comma j. Means here j here will be j instead of y. So j plus one value is less than one less than m. So in this case, the robot will be able to move on the right. Now now we have the case as we are standing on I comma j. So whether we have two cases. As we have already took cases that whether it move on right or left. So we have already decided that we are moving. We are taking first case. We are moving on the right. Now we have two more case is that as we are moving on right now, if the coin value is positive or negative, if the coin at particular state is positive or negative, so if it value is negative, so in that case we need to check whether we use our special ability or not. In this case, if we are using a special ability, let we as means using a special ability, or we can say special power. Here we are using a special power. So here we are using a special power. So to use our special power, first we need to check whether we have some special power left or not. So which will be given by our variable sp. So if sp is less than 0, it means is sp is greater than 0. In that case, means some special power is left. So we have two possibilities whether we are using this special power or not. So if we are using this special power, means using this special power. So we will store it as and the value will after uh, using special power which will get from coordinate while traveling from a coordinate I comma j to the bottom right corner. We will store it as in a variable rv1. So as we are using special power, so the special power will neutralize the robber. So the right value will be given as a max amount with I comma j plus 1, and the special power as we have used. So special power will become minus 1, L minus 1, and n comma 1, and we are passing the point same as we have. Now, if we are else, if the special power, so here the second case. Suppose if we have a special power and the coin values or that particular cell value is negative. So we have two possibilities whether we use special power or not. Not in the second case, if we are not using a special power. So in that case, int rv2 will become, we will store its value as we are not using special power. So we have to add the particular cell value, and the rest of value will be given by the dp. And now our special value will remain L instead of means SP. Or it is not L, it is SP. As the special power will be here as SP. Here the special power will become SP. It will remain SP. Now we will N comma N and coins. So these are the two cases which we get if our cell value is negative and we have some special power left. So in this case, some special so the as we have to maximize, so the max of these two values will be stored in our right value variable well which will store the max of rv1 and rv2. And the second case is that if we do not have any special power left, although our cell value is negative, so simply what it do, right value will take the max coins, it will be this similar as that of second case of SP if we have some special power left. So in this what we happen J comma 1 and SP and N comma 1 and coins. This is this will be the case when we have this will be the case. This is all the case when we have a particular coin value is less than 0 and if we have particular cell value is less than 0. So we have two cases. Either we have some special power left or we do not have any special power left. If we have special power left, then we have two more uh, cases. Either we use special power on this particular cell or we will use on some other further upcoming cells and we are not using at this particular point of time. So these are the two cases which we get if we have some special power left. If suppose we do not have a special power left, so we, we can do and nothing. So in that case, we have to add this particular coin value. And the second case is that and else case if the coin value is greater than 0. In this case, the right value will be similar to as that of uh, so similar. If we can't do anything as if suppose the if right value is greater than 0. So as we have to maximize this, so we can take we take the cell value very and we will do n command and we will take the cell value it will be profitable to us. So the first case which we have solved is that if we will move towards this right and thus similarly we will solve for the down. First we check if it is feasible to move down or not. If it is feasible if it is feasible then we will move down. So then we will check what whether our coin value is less than 0 or not. If it is less than 0, so we will check whether we have some special ability left or not. If we have special ability left, so first case will be, either we want to use our special ability or not. We are using special ability or not. In this, we are using our special ability. So it will neutralize us and neutralize the robber. In this case, it will become j comma 1 and the special ability will be subtract reduced by 1 and n comma 1. For that, we will pass the coins. And second case will get is not using what we are doing, not using special ability. In this case, we will store in the second variable and we will add the coins I comma j and next amount I plus 1 comma j and the special ability will remain same as present initially. So it will be coins and we will store the max of these two in the down variable which will store the max of dw1 value and dw2. And the second case, if we do not have any special ability left, so simply the down value will be the points of I comma j and plus so I comma j plus max amount I plus 1 comma j comma sp comma n comma m comma points. Sorry, m comma points. Okay. In the second case, if we already have our points value or cell value is greater than 0, so it simply does what? It simply store that coin in him. So in this simply does max amount as plus 1 comma j and sp and n comma n comma points. So we get both our we these two this give the maximum value which we will able to earn when we move towards the down from a given particular cell, and this will give the maximum value which a robot will able to earn if we move from towards right from a given cell. So as we have to maximize the value, so we need to store maximum and at that particular state which will be the store the maximum of right value and the left and the down value. This was the whole problem, and here we will what simply does we return max amount uh, Initially we are at 0 comma 0 and our SP was 2 and what n comma 1 and we have passed the coins. So that's all. This is all the problem which is we have seen. Uh, Now let's run it once. That is good. Now you can see that it is clearly passing these three cases. Now let's submit this problem. So it is passing. So it was a basic DP problem which we can solve either. This is a top-down approach. We can solve it as a bottom-up approach as well. So thank you.